Hey guys, what's up? Eddie Aho here with KissAnalog.com. Alright, so today what I planned on doing was putting this Class D and this power supply in this box. Had it all set up. I'm going to show you the pictures of the setup and yeah, stick it in the box and do some final tests. Turns out it's not going to fit. Ay, ay, ay. This box turns out to be a little bit smaller than my last one. I didn't realize. I thought it had the same dimensions. I have another box, but it doesn't have the cutouts. So that's going to put me behind. Well, the good news is, and from the title of the video, you may already know, is I've got another amplifier. This is ICEpower 125ASX2 SE. Okay, so this one, look at that guy. Pretty cool, huh? So ICEpower. Alright, what's neat about this, look at that, smaller than that power supply, and it's smaller than that Class D. This one, you know, maybe doesn't put out the power that that one's spec to, but probably puts out pretty close to the same power. I mean, with low distortion. So this one has the power supply, switching power supply, and the Class D amp, all on the same board. It's 2 channels, and you know, they show a lot of different I'm going to show you this data sheets, okay? We're going to jump over here. I'm going to walk you through the data sheets on this. But one thing I just want to mention on this is ICEpower was founded in 1999, I believe. And the CTO, the Chief Technical Officer, he is also the Chief Designer. In college in Denmark, the university, he was at the Technical University of Denmark, I believe is what it's called. And he got, man, he just, stars were aligned for him. He, you know, went to work for Bang & Olufsen while he was in university, and they actually, you know, liked what he was doing, and they gave him research time to go off and develop Class D amplifiers. So he's written some really cool papers and really in-depth, detailed papers. He's got a PhD, so yeah, he's something else. And anyway, he's done such a great job with Bang & Olufsen, and if you guys, I think you probably know who they are. I'm going to talk a little bit more about them in the papers I'm going to show you. But anyway, yeah, he developed these ICE amplifier boards, okay? And there's some ICE chips on this thing. And so I'm going to show you the documentation and show you what power this thing's going to put out. It's going to fit nicely in this box. It's going to be roomy, but other than this really cool heatsink, which I'll bring the camera in close and show you this, you're not supposed to have to do any other cooling. I might put this small little fan on it. We'll see. We'll see. Once we start testing it and let it run at power for some period of time, we're going to see if it really does stay cool enough. Now, Amir at Audio Science Review reviewed this, and you know, he liked it, so I think he gave a thumbs up on it. That was in 2019, I believe. So this thing's been out for a few years, and yeah, I'm going to stick it in this box, and I'd like to hear from you guys. Comments down below what you've heard of this, if you have heard of it, and let me know what you think, and if there's been modifications, improvements, anything like that. But it looks to me like it has really nice components on it. So what we're going to do is I'm going to show you the data sheet on this thing, kind of walk you through that, show you the specs, and then we'll come back over and take a close look at this, and then we'll do a quick test. Alright, so then I'll put it in the box. I'll come back with another video showing you the construction build and some final tests. Alright, then it's going to go off to my friend's house. He's going to do some listening tests. So yeah, I think this is all going to come together pretty quick. Alright, so All right, let me know what you think, and let's look at the data sheet, and then we'll come back over here.
Okay guys, so ICEpower ASX2 series, pretty cool stuff. Let's go ahead and take a look at this. Now these are, you know, actually designed and made for manufacturers, and you know, that's who I am, right? I'm a small-time manufacturer. But yeah, maybe we'll continue to make these. So here's the 3 different boards you can get. The one I have here is right here in the middle. This one right here. Okay, I'll show you the board up close and everything. But it's really cool because it has this heat sink. There's an inductor under here and an inductor under here. And there's a couple devices under here, Class D. So we have our AC power coming in here towards the middle bottom. And it's going to the left through the fuse, an X2 capacitor, combo choke, and some Y caps, and another X cap, and we have a bridge rectifier right here, and then we come off to a poly cap and to our storage capacitors. Okay, so here, let's just come back out. Here is the specs for these different amplifiers. Okay, again, this one I have right here, 125ASX2, so 550 watts and 4 ohms. That's if it's bridge tied load. And the board I have is in a single-ended application, so there's 2 outputs on the board, and you know, 2 times 125 watts and 4 ohms is what it's claiming. Okay. Now this says 1% THC plus N, plus noise. So, okay, what else does it say? See, what else does it say here? They talk about the power density. It's very dense board, 20 watts per cubic inch. It's pretty impressive. They've done a really good job laying it out, making things tight so that you can put things in small containers. Innovation of freedom. You know, you can use them in bridge tied load. You can use multiple boards in a box, get 8 channels, all kinds of stuff. So for manufacturer, all kinds of things. Speaker loads from 2 ohms up. Okay, and then application convenience. So, you know, it's got all these different specs right up here. Okay, the one I have is right here in the middle. So let's come over and look at the specs. There you are. So 20 kilohertz bandwidth, full 20 kilohertz bandwidth. We'll see what that means. 115 volts, or if you're in Europe, 230. We have short circuit protection, overcurrent protection. Those are 2 different things. Short circuit is obviously an overcurrent, but it's extreme. Sometimes overloads are even worse, where you're just pushing it past the specs and not quite enough to go into short circuit or current limit. So you have this overcurrent protection, which is kind of a current limit. So thermal protection monitoring. So we have some outputs. Overcurrent protection monitoring. These monitoring ones, that means that it has a connector on the board where it'll send out those signals if you have those, and you can use those to do other things. And it's safety pre-approved, EMC pre-approved, and RoHS compliant, which, you know, that's a lead-free thing, right? And that's the board I have right there. Okay. So, audiophile performance, look at that. Let's blow that up and take a good look at that. Okay, audiophiles, Class D amp is here. So there we go. There's some specs for power and bridge tied load and all that kind of stuff, and you know, all that type of stuff. So nominal power 1% is the 2 times 125, and the bridge tied load you get 450 watts. Now look, here's maximum power 10%. We know that means a lot of clipping and all that kind of stuff. So 550 in bridge tied. So we come on down, nominal power 1%, 8 ohms, 2 times 65. So I'm really thinking this is with real clean power, like 0.0 something percent. We'll see later on. I think we can count on at least 2 times 40 watts. And then that means it would double cleanly at 4 ohms and double again cleanly into 2 ohms and give you the full power. I think so. If we rate it that way, we get a nice linear power from 40 watts to 80 watts to 160 watts into 2 ohms. So it's kind of what I'm shooting for. And here we go. Just dampening factor, it's greater than 500. It's ridiculously large. THD plus N plus, or at 1 kilohertz 1 watt, it's 0.003. So that's the typical way of measuring THD, and that's just ridiculously small. All right, and then let's go on. So there's the lower power guy. Whoops, let me zoom back out. All right, so zooming back out again, we have our curves over here. Let me just zoom in on this one up here. This is the board we have right here. Okay, so this is your percentage right here. Here's 0.02% right here, and red is 6.67 K hertz. Okay, and then 1 kilohertz is this green one, and 100 hertz is this blue one down here. So, and this is a 230 volts of the input. It's too bad they didn't show this for 120 for for the rest of us, right? But anyway, you can see the distortions are really low out here to about 50 or 60 watts, and then they climb up. Then that's the higher power unit. And okay, next page. This is another unit right here, the lower power unit. This board down here in the left corner. And breakthrough in technologies. Let's look at this stuff. So ICEpower, they talk about 0 voltage, 0 current switch mode power supply topology. So they're switching to 0 voltage, 0 current. I think it's probably 0 current at the rectifiers on the output, 0 voltage at the input. So it's clean power is what they're suggesting. That's what that would mean, efficient and clean power. And then they have this adaptive supply pump cancellation. So yeah, so for audio, sometimes you can get the audio rails pumping voltage back in from the speakers, right? And so they've got some circuitry to prevent that. And then they also have this HCOM modular topology they talk about, and this MECC feedback architecture. So they've got a couple things, the way they modulate it. It sounds like that if we look down here in the left corner, I'll zoom in on this. Okay, so I zoom in on this, HCOM, hybrid controlled oscillation modulator. So it's not a fixed frequency, it doesn't sound like. It sounds like there's some kind of hybrid thing going on, and it's probably to keep the gaps between pulses really to a minimum, so it's easier to filter and cleaner power on your Class D out. And then they have this multi-variable enhanced cascade control, patented technology, Bang & Olufsen. So ICEpower, so variable frequent, multi-variable enhanced cascade control. So it sounds like they have feedback, not just universal output to input feedback, but probably multi-stage feedback. And that is supposed to be the way to do it to get really clean feedback control. So next steps, this is some more interesting information here. I'll just let you read some of this stuff. And by the way, here's their email address in case you want to write to them. And what I want to point out is you guys may have heard of Dr. Carsten Nielsen, and he was at the University of Denmark, Technical University of Denmark, and he got lucky, and well, not just luck, but through his hard work and his Class D interest, and the interest that he had, aligned with Bang & Olufsen. So they kind of gave him a green light to do his research, and they came up with some really great Class D stuff. So these ICEpower amplifiers, if you haven't heard about them before, you might want to look into it. They're very well respected. So they got some money so they could put really, plug into their R&D. So they've done a lot of work on this stuff, and companies down here like Bang & Olufsen, obviously, Bowers and Wilkins, Pioneer, Samsung, Toshiba, Sanyo, and Audi are some of their clients. So good company to be in. And here's their global partners right here. So I'm over here in the States. That looks like a little bit. I'm over here, Utah. Looks like they got a square here, one up here, that must be Denmark, and then one over here, that must be Japan. So, yeah, they've got them kind of spread around. I guess I can look down here and I can see the addresses here. So this is in Illinois, this square. I was thinking that looked like Chicago. It's the Great Lakes right there. There's the Great Lakes in USA right there. And so we do have Denmark and we do have Japan. Is obvious. I just had to look down here. They should have moved these two, alternated these two, right? So they line up with the dots. All right, now what I want to show you is the data sheet. Version 1.9. This is the data sheet for this. It's 31 pages. So I'm just going to peruse through this kind of quickly. Here's a close-up picture of the amplifier board, the top of the amplifier. You can see this big old ice chip here. You see the EMI filter that kind of starts here in the middle of the bottom, kind of curves around up to the left side, and then we come into our first converter. It's I think it's a type of an SCR type converter, kind of like an LLC, and so they come off with two outputs, plus and minus, and we can kind of see some of the diodes here. There's two more diodes on the other side of the board. These are FETs acting at synchronous rectification. Synchronous rectification feeding these capacitors, these bulk capacitors for the plus minus output. And then our Class D amplifier right here with our common mode choke right here. And you notice, you don't see it, but underneath the heatsink there's a inductor here, and there's an inductor here, and then the Class D amps in the center. So it's really interesting heatsink. We'll take a closer look at that. Here's the table of contents, just so that you kind of look at that. Disturbance of mains they talk about, output impedance, power and frequency. Just they've got a lot of stuff here. Okay. Power supply protection, amplifier protection, local and global, timing diagrams, thermal design, physical dimensions of drill pattern. I think I'll need that. Okay, and here's your general description. They talk about the HCOM and that MECC control. So a couple patented things they have for this. And some, here, let me zoom in on these specs and key features. So here you go. This is bridge tied load. We want to look at this single-ended, this one right here. So there you go. Now again, that's at 1%. So, if we want to say our clean power is 40 watts into 8 ohms, it'd be 80 watts into 4 ohms and 160 into 2 ohms. And we'd have plenty of dynamic room up to where we'd get 1% distortion. So, or even 10% for that matter. So, yeah, we'd have lots of dynamic range. Maybe at the high ends, maybe we get more distortion, but playing music pretty loud at that point, right? Okay, now we have plus minus 24 volt unregulated auxiliary supplies coming off in case we need to use that for preamplifiers or something else. In case we need to use those for, So we have a plus minus 24 unregulated auxiliary supply. We might want to use those for some other amplifier or something else in the box. So except for they're pretty low power, so it's probably maybe a preamp before the board, maybe some other kind of signal processing that you might want to do before you feed the board. And then over on the right, key features, is fully integrated power supply and audio amplifier all on one board. Rugged construction, thermal protection, again, all this. Look, sound optimized soft clipping. So they have some kind of thing there where they soft clip. And your EMI conformance standards. Now that just means basically they designed to it, and the final thing would have to be tested in your box. And here's all the release notes. Like we said, this is release 1.9, so it looks like pretty minimal type modifications. And block diagram, pretty interesting. All right, I zoomed in on the block diagram. This is really interesting. Here's our EMI filter, our live power, live and neutral, hot and neutral, whatever you want to call it, coming in through your fuse, EMI filter rectification, and then your DC-DC converter with the isolation. That's that transformer. And it looks like it's going to give a plus minus 5 volts plus that plus minus 24 volts, whatever it is, to the power amplifier stage. I'm guessing it's that because it's all they do have plus minus 24 coming off here, but it could be something else. Output stage 1 and 2, and here's our input filtering block where our channels come in and our grounds and all that kind of stuff. So here's that MECC control, the feedback, and the HCOM, the modulation. And this is our board. This is where we make our input connection right here. And this is the output, the auxiliary supply. Here's our input signals right here on this connector. And speaker outputs right here. So there we go. And this little line right through the board right here, this is the isolation stage. Just a transformer, between these guys here. This is where you're isolating your primary power on the left side to your secondary power on your output side. And yeah, so pretty cool. Oh, and then there's a jumper right here if you're running 115, or a jumper up here if you're running 230. Okay, these are the pinouts on those connectors. Okay, you can see that stuff, the ratings for all the inputs. I'm just going to kind of scroll through this so you can look at it. Here's the power specifications. And one thing I want to mention, they're showing some power with the thermal and all this kind of stuff. But down here, it looks like here's auxiliary supply. Oh, here's the mains voltage output power within specified range. So, typically plus minus 24, it looks like. But what I want to show you is this efficiency up above. This is pretty incredible. So, you can see the efficiencies. The worst case, 75%. That's when you're 100 watts into 4 ohms. So, and then it gets up in the 80%. So that's pretty crazy. Now, this is going to take into account the power supply and the Class D because it's all together on one board. So it's pretty impressive. And what that also means is you don't need heat sinking because you're not dissipating a lot of power on this board. So there's no additional heat sinking required. At least that's what the brochure says. And from the specs, I tend to believe that. General audio. Here we go, 4 ohms. Here's 115 for us here in the States for 2.7 ohm loads, 160 watts, 8 ohm, 58. And this is with THD at 1%. So still kind of on the high side, right? And then we continue on with our table down here. one thing I want to get to is this one right here, THD plus N. So this is THD plus noise, and look at this, 0.003 or 0.01 max. So that's pretty incredible. And that's a 1 watt. That's the normal place you rate these amplifiers. So 1 watt output. The bandwidth, 8 ohms, 120K, 4 ohms, 90K. So you're not going to, inside the audio band, we're not going to worry about that. It's going to be, look, from 20 hertz to 20K. Look how flat, plus minus 0.5 dB max. And typical 0.15, so that's very flat. The lower bandwidth limit is 1.5 hertz, so that means you guys that like that boom boom, it should play all that really low, 10 hertz, 20 hertz stuff really well. 20 hertz is about as low as we can hear, human hearing, right? But yeah, no worries there. Now here's bridge tied load stuff again. So they go through some more tables for that. So disturbance on the mains, I just want to point that out. They're talking about that EMI filter on the front. It's filtering everything. So, all the noise and everything that's present on the AC lines, that EMI filter should help isolate this amplifier from that. And you notice it doesn't point out that you need a really expensive power cord. Right? Yeah, because that's just absurd. So there we go, and special care and component section has made this amplifier capable of withstand surges up to 8,000 volts to avoid damage to the amplifier. So that's pretty crazy, pretty awesome, right? Now look, this is the robustness that we're talking about, vibration, 2G RMS, bump, 10 Gs, shock, 70 Gs. And this is in 3 shocks in 6 different directions, guys. 1,000 bumps up here for the bump, 6 directions. I mean, this is pretty impressive, specs here. So yeah, it is built very robust. Here's your sinusoidal and your random vibrations, and look, 2 hours in each of the 3 directions. So you're not gonna have to worry about parts falling off this board. Now look at this. Here's the bandwidth. Here's the gain, up at around 25 dB. And, I meant to point that out in the spec, guys. But anyway, it's right here. It's right around 25 dBs. And pretty crazy. And this is the phase down here. You can see the phase stays pretty darn flat. Here's 0 right here. So it's just above 0. It's like, say, 10 degrees maybe right here to start, and it drops down to 0 right around 2K, and at 20K from 10 to 20K it's starting to drop out about 20 degrees right in the 20K range. So that's pretty darn flat. The only way you can maintain this even flatter is you bring out the bandwidth even further, okay? Which, for a Class D or really any kind of amplifier, these high frequency noises, you kind of want to filter those out. So a lot of amplifiers start to roll off even before, these frequencies. So this is really good. Pretty darn flat. There's bridge tied load mode. And then we have our harmonic distortions, okay? And our bandwidths and that. And you can see, if I come in here close, you can see the harmonic distortion. This is 0.02 right here. This red one right here is, which one is that? We got red, green, and blue. So 100 hertz, 1K, and 6.7. So 6.7 I think is the high one. The other two guys down here, we already saw that curve once before, right? And then, yeah. So, and guys, this one right here is, all right, see these two curves right here? Total harmonic distortion and noise. So, I mean, look how clean that is. You can see the spike up here, right around, 38, 36 dB, something like that. And then, man, there's a spike right here. This is minus 130 dB. That's ridiculously low. And this goes down to minus 160. These AP devices are able to do that. And then we got another spike over here. But anyway, these spikes are so low you can't even hear them. Regardless of the signal to noise ratio, the ratio between these, doesn't matter. These are way too low to even hear. There's a bridge tie load thing. Then right here we go into this intermodulation distortion, and this is some interesting stuff. We're going to talk more about this kind of thing here, and I'll see if I can do these tests myself to kind of point out how they're done. But what I want to just point out briefly is 18K and 19K. You got two frequencies, and it's kind of hard to see them, but because this one's in the grid. But you got these two frequencies up here, okay? They're 1 kilohertz apart. So what you get is you add them together, you subtract them, and you get these little intermodulated things, these things that are just factors of these two frequencies bouncing against each other. And what I want to point out is 100 or minus 90 is right here. So this first one is minus 90, where up here they're around almost minus 20. So there's like 70 dB of change. And I think back in the day when they came up with these kind of tests, they wanted to be, I believe it was 40 dB difference so that you wouldn't hear it. And this is like 70 dB. So pretty impressive. So you guys that are worried about Class D amps, I mean, these things look pretty. Now these have lots of spikes. This is, I'm not even sure exactly how they did this one. This is a TIM, and this is a transient intermodulation test. And let me see. What I want to show you is I was looking at this, and I think what it looks like to me is they're using a 3 kilohertz tone, or it's just a little bit more than 3. I forget what it is. We'll talk about this again, but it's just about 3 kilohertz. So there's one tone right there. So you see that peak right up here around minus 20. And then I believe the other one is right here, 15 kilohertz. So then they put a 15K, and there's a ratio. They don't put them at the same amplitude. You can see that, right? And then what happens is one is modulating on top of the other one. So you get all these intermodulation distorted peaks, and you're looking for things that are in between that shouldn't be there and how low they are. And first of all, this minus 110 right here, see, most of these peaks are under that. So that's, again, ridiculously small. Some of them are under minus 90, okay? So we'll talk about that again, but I think what we're basically saying is this looks impressive. Okay, and power versus frequency. This is the output impedance. So the output impedance looks pretty darn low, even here at the higher frequencies where it's less of a concern because your speaker elements at those high frequencies have pretty high impedance too. And then there's this one. Now, the SE is the one over here on the left, or the single-ended mode is here on the right. So this is the one that we kind of care about, and that's why. So right down here, I mean, it's really low impedance, and then it starts to rise a little bit. But even here at the peak, it's still under half, a volt or whatever. So we'll do some measurements on ourselves and talk more about that later, okay? And yeah, here's some information here. So you can read through this stuff and give me comments down below and tell me what you think, okay? Dissipated power versus output power. So let you just take a look at those things and let me know which tests you'd like me to do. We were talking about the overcurrent here and the thermal monitors, what's kind of going through the features. There's an enable pin. You can turn it on and off. Again, if you want to use those auxiliary supplies to run some other signal processing, you can do some stuff. And so just kind of scroll through the rest of this thing. Here's our protection features. You know, low voltage protection, overcurrent protection, temperature protection. That's for our power supply. And then we have our amplifiers, and we have local protection here for each stage, and high frequency saturation protection and overcurrent protection on our output stage. And then we have temperature, over temperature on our amplifier. So not just on the power supply, but also on the, Class D. So lots of protection built into this. And here's some more talk about those. Here's our input stage, okay? It's going to come through a 100 ohm resistor, 1 nanofarad cap, so pretty high frequency, and then a 270 volt cap, so that's our kind of voltage divider a little bit, and 2.2 mic, pretty good size cap with a 47K. So that's how we get down those low frequencies. And there's your BTL. We'll kind of skip over that since we don't really have it. Yeah, there's our more discussion, physical dimensions. So there we go. Pretty impressive size for all what this thing does, having a power amplifier and power supply. There's my drill pattern I'm going to need. Safety standards, EMC, and ESD. So yeah, we got all kinds of protection. And then they just even go into the details of packaging and storing. Because if you are a manufacturer, you want to buy their boards and put them in your own boxes, sell your amplifiers with ICE modules, then that's kind of what it's meant for. So hope you like that, and let's get on to the next thing. All right, guys, I'm getting ready to test this new Class D, the ICE Amplifier Board. Let me show you the display I put together on this. I haven't tightened the knobs down because I'm waiting to tighten up everything. But this panel, I'm kind of wondering if you guys have any ideas how to install that. I would think there'd be like a little screw with maybe here and here with a little metal strap that goes across here to hold it down, or something, some way. But yeah, let me know what you guys think. I have some industrial hot glue that I could use. I've got 2 log pots here. And so that's kind of set up, ready to go. I have to calibrate. I got to run 12 volts to this, 5 to 12 volts AC. And then calibrate those VU meters, decibel meters. And yeah, I've got this panel here put together as well. These are pretty nice banana jacks, I think, and some nice RCA. They're all gold plated, and our IEC with the fuse and spare fuse in there. So again, I'll wait to tighten down all these. I guess they're probably ready now. I was just installing everything, making sure I had everything in there before I tightened it down, but I guess it's time to tighten them down. Alright, and I got the feet put together, all ready to assemble the box, but I thought I'd do just a cursory, just an initial power up, make sure I got a good board, you never know, right? So I've got the AC power cord coming in here, I've got the inputs, and I got both inputs tied together so I can fire up the left and right channel with one signal. Then I've got the speaker outputs here. And I'll trim all these cables and make them all fit when they go in the box. But right now, just for testing, so I've got the 2 8 ohm loads hooked up. I've got my Keithley meter here on one channel, so I can measure the harmonic distortion. And then I've got a differential probe on the output of the other channel. And I've also got a differential probe right down here. Yes, here, let me move the camera. Sorry, couldn't see the input. Here's the generator input, the other differential probe, so we can look at them on the scope. But for now, to start off with, what I want to do is I want to show you using this guy.
I've got it in decibels. So we'll look at the input and the output and see what the decibels are. It also reads out the frequency. I've got the Junk Tech generator, and we'll put in 1 volt RMS, okay? Let's go ahead and do that and see what we get. See what the gain of this thing is. Now, the gain on this ICE amplifier is supposed to be 25 decibels, so let's see if it is. Okay, I've got it turned on. I'm going to crank this up to 1 volt RMS, which is 2.8 volts peak to peak. 2.828 about. Okay, so I'm getting my probes down here where I guess you probably can't see them, and that's almost 0 dB, so that's right, and it says 1 kilohertz. Okay, now let's go to the output, and we got 24 dB on that one, and 23.98. Pretty darn close to 24 dB. So yeah, pretty close to what it should be. Alright guys, so we're going to turn on the power and you'll see the signal come up. I got them out of phase so that you can see them, otherwise it'd be on top of each other. So I just put them out of phase so you can kind of watch. And here's our 2.828. Okay, and output is 17.84 volts, about 55 volts, about 55.7 volts. So getting close to max peak output, I guess. And yeah, there's our input, 1 volt RMS. So there we go. That's what it looks like. And if I increase it, here I'm at 1 volt RMS, I'll just go up a little higher. And you can see we're starting to kind of hit the top of the waveform there. So we'll go back down to 1 volt RMS right there. And I'm going to freeze that. Okay, so there we go. Looking pretty good. I think we're ready to put in the box. You know what? Actually, I think I'm going to turn it back on and let it run for a little bit and see how warm it gets just sitting here on the bench, open air. Okay, so both channels have 17.8 volts coming out, and we'll just see how warm it gets. I'll come back. Alright guys, we've been running about 10 minutes and things have kind of settled in, I think. I've got that little cursor pointing at the heatsink. It's about 45 degrees, and when I look around, the hottest thing is that thermistor right here, right up here. It's like, that thermistor is like 90 degrees. Let's see if I can get this little pointer on it. It's kind of hard to single out, but you might be able to see the hot spot jumping around. I'll take a picture of that and put it on the screen here. Alright guys, I'll take my the Ericsson device I have here. It's really nice. I'll just do some spot checks here, and if I go down here, you can see right, if I try to get underneath the board, right here close to the edge of the board, it's about the hot spot, about 50C. I mean the hot spot around that heat sink. Transformer doesn't look too bad. And then I get down here by that thermistor, and if I find it, there we go. Yeah, see, it jumps up to about 68. If I can find it. And then our combo choke, not too bad. I was trying to get the bridge rectifier because sometimes they get a little warm, but about 39 degrees maybe. And there's the switching transistors over here. And you can see what they get to. Then I'll get the switching transistors back here. Okay, there's a hot spot there on the switching transistors back there. So still, even this surface mount transistors, but yeah, you can see it's kind of stabilized. It's been about 15 minutes almost. So I think things are staying relatively Cool. Alright guys, so it's been about 20 minutes probably, pretty close, and I'm trying to find a hot spot right here. And that's about the hot spot I get there. I find right down by the heat sink there where that chip is and all that's kind of a hot spot. And switching transistors. There we go. And then we get these. There we go. That's a hot spot. So, but still that thermistor, if I can get that thermistor in the picture, right, yeah, see that thermistor, that little guy right down there gets pretty hot. But, yeah, been running for a while. Oh, and the resistors, by the way, wow, I thought I could smell something getting hot. I think the resistors are getting pretty hot. 200 watt resistors over there. Alright guys, oh hey, by the way, you can get one of these or a t-shirt, links down below. It's about 38 watts in each one of these 8 ohm. Wow, they're still pretty warm. 38 watts into each one of those 8 ohms, and a total of about 135 watts coming in from the power supply. So yeah, that's about 56% efficiency. It's not as good as I would have thought, but you know, between the amplifier and the power supply, still would have thought it'd been a little bit higher, but oh well. Hey, so 38 watts clean power with 1 volt RMS coming in. I say clean power because the Keithley, this generator puts out about 0.5% distortion. I didn't see it really climb any higher. Once we get it in the box, I'll put a clean signal in, take some more measurements, see really what it looks like, and we'll look at the spectrum, things like that, and then I'll put some music into it, and I'll send it off to my friend for a listening test. And yeah, he's just an audiophile of sorts. He doesn't consider himself an audiophile because he doesn't really look at all the technology and all that stuff. He just likes good sound. But anyway, 1 volt RMS puts out about 38 watts in each one, so that's pretty clean. And then we have plenty of room for dynamic power. And then 4 ohms, it should double that, no problem. So yeah, I think this thing should be pretty clean amplifier. That was with 1 volt RMS input, so I think we can do a little bit higher than that. When we get it in the box, I'll put a clean signal in, we'll take it up and see really, you know, how it's operating, okay? But it's about 24-25 dB gain. That sounds about right. And what do you guys think? This ICE amplifier. I'd like to know what you guys think about that or what you've heard about him. I'm just really curious because since I've read the thing about Dr. Carlson and all the work he did on Class D's, that's why I picked this guy up, because I thought, wow, maybe this can be, you know, a reference Class D amp. We'll see. At least it'll be one of the references. Alright guys, hey, 2 thumbs up to my patrons. I'm going to have to buy another box for that other Class D amp. It'll take at least a couple weeks for that to come in. So, yeah. And 2 thumbs up to you guys. You hit that thank you button. That's a way to buy a cup of coffee, something like that for me. Really appreciate that. It's awesome that, you know, people do that. And yeah, I want to thank all you guys for watching the video. That's a free way to support the channel. You can also click the links down below for multimeters or whatever you want to buy that I have linked down there. That's another free way to help. And then lastly, hit the thumbs up. That helps too. That helps YouTube analytics and all that. You guys know that. So, alright guys, pretty excited to get this in a box and do some final testing. So, I'm going to get back to it, okay? Alright guys, hey, thanks a lot for watching, and we'll see you next time. Back to work.